So today we'll solve this problem in differentiation at first. Okay, like we need to find dy dx when x to the power y into y to the power x equals to e to the power xy minus 3x. So this is the given expression. Okay, now we need to find dy dx, and we can see the differentiation would be done with respect to x as dx in the denominator. Okay. Now, from this expression, what we can write, if you remember in my last session, I told that whenever you see that any function to the power function, this kind of form, or e to the power xy, this kind of form, so we will try to impose log on both the sides to simplify this kind of expressions. Okay. So if we impose log, then log x to the power y into y to the power x would be equals to log of e to the power xy minus 3x, right? I'm just putting log on both the sides. Okay. Now, if you remember the basic formula of log, then you would be remembering that log a into b would be log a plus log b, right? Like log a plus log b. And we cannot break the log whenever plus or minus sign between the functions. Okay, so we need to keep this log as it is. Now, if we differentiate the whole logarithm function on both the sides with respect to x, what we'll get? We know the derivative of log x is 1 by x. So, derivative of log x to the power y would be 1 by x to the power y. And we need to again differentiate x to the power y with respect to x, where we need to consider y as another variable. Okay, so if we consider y as another variable, so we need to do ddx of xy. Okay, like ddx of x to the power y plus similarly 1 by y to the power x into ddx of y to the power x equals to 1 by, as we know, ddx, so if we assume it as x, so the derivative of log x would be 1 by x. So it would be 1 by e to the power xy minus 3x and ddx of e to the power xy minus 3x. Right? Clear to this point? Okay. Now, what we need to do? We need to do the differentiation of x to the power y. Okay. Remember, y needs to be considered as, y would be a variable. It should not be considered as a constant term. Okay, but we need to differentiate this expression with respect to x, right? So, can we write 1 by x to the power y x to the power y minus 1 into dy dx. Why I have added dy dx? As y is a variable. If y is a constant like 2 or 3, then we would have done only 2x to the power 2 minus 1. As we are differentiating another variable with respect to x, so we need to multiply dy dx. Similarly, 1 by y to the power x ddx of y to the power x means, if you remember the formula ddx of a to the power x, it is a to the power x log x. Like ddx of a to the power x equals to a to the power x log a. So similarly, it is ddx of y to the power x. It would be y to the power x into log y into dy dx. Why I have added dy dx? The same logic, as y is also variable here. Okay, and in the right hand side part, what would be there after the simplification? Let us see. Like 1 by e to the power xy minus 3, so I am keeping this part as same. Okay, and ddx of e to the power xy minus 3x here. Okay, so ddx of e to the power xy would be e to the power xy at first. Okay, and we need to again differentiate xy part. If it is ddx of e to the power x, then it would have only e to the power x. As it is ddx of e to the power xy, so we need to write e to the power xy, and again we need to differentiate this xy part itself. So it would be ddx of xy. Along with it, what we need to do, ddx of 3x. As you can see, as in the expression, there is ddx of minus 3x. So ddx of minus 3x would be minus 3 only. Okay, so I am putting it here as minus 3. Now, if you understand up to this point, so I would request you to take a note of it, because I need to clear some of the portion from the beginning to complete the solution. Okay. So after this part, what you would write? We would write 1 by x to the power y, y to the power y, x to the power y minus 1 into dy dx equal plus, we can cancel out this y to the power x and this y to the power x. Okay, so what is remaining? Log y dy dx. Okay, plus log y dy dx equals to, in the right hand side part, what we get? 1 by e to the power xy minus 3x, and within the bracket it would be like ddx of x into y means y plus x dy dx. If you apply the formula of ddx of u into v, you would see that ddx of xy would be y plus x dy dx. Okay, so minus 3. Now I am clearing this last line which I have written little while ago. Now let us take all the dx at one side. Okay, like from here, can I write 1 by x to the power y into yx to the power y minus 1 plus log y. From here I am taking log y, and from here I am taking this expression. So this plus this can be taken within the bracket, and dy dx can be written, right? Similarly, from here, okay, like can I write 1 by e to the power xy minus 3x, and just see carefully. Okay, what we need to write is y e x to the power y plus x e x to the power y dy dx, and the minus 3 at last. Okay, now we need to take out this dy dx part and need to take this part into left hand side. Okay, like as of now, let's keep the left hand side as it is for this step. So we can write y e to the power xy divided by e to the power xy minus 3x. Please follow step by step. This is very important to understand. Okay, just follow step by step. So after that part, what it would be, like plus x e to the power xy divided by e to the power xy minus 3x into dy dx, and in the last part minus 3 into this part. Okay, minus 3 into 1 by e to the power xy minus 3x. Fine. So now we will take this part as it contains dy dx in the left hand side. So what I will get? I will get 1 by x to the power y into yx to the power y minus 1 plus log y minus x e to the power xy divided by e to the power xy minus 3x. That would be under dy dx, right? As we have taken this part into left hand side. And what's the remaining part? This one and this one. Okay. So it would be equals to yexy divided by e to the power xy minus 3x minus 3 divided by e to the power xy minus 3x. So that would be the answer of your question. Don't confuse with the steps. Like this steps is this one and this step is this one. Okay, so do not get confused with the steps. Okay. Okay, so I think you would be able to understand. Just follow from where I have started, how I have converted the log term, I mean how I have imposed the log on both of the sides, how I have implemented the formula of log. Thereafter I have done the differentiation of both the sides. So what we need to do, as we need to find dy dx, so we need to keep in mind that we need to take all the expression which contains dy dx to one side and the another expression which do not contain the dy dx part to another side. Like dy dx from here, what would be dy dx? This part divided by this part. Okay. So I hope you would be able to do that part, right? Okay. So we'll move on to our next problem. Now we will solve this problem on differentiation. This is an important one. Okay. Just we need to in fact prove that dy dx would be equals to y by x, and we have this expression. I hope you can understand that this kind of expression can be simplified only by imposing log on both of the sides, as I have mentioned in earlier videos of differentiation also. Okay, like if we impose log on both the sides, what I will get? I will get log x to the power m into y to the power n equals to m plus n log x plus y. I am not going into the details that how m plus n have come to coefficient and log x plus y I have written, because this is very simple generic formula of log, and here log a into b, it can be broken in log a plus log b. Okay, like log a plus log b means y to the power n equals to m log x plus y plus n log x plus y. Not required this part. Now after this simplification we will differentiate both the sides with respect to x. Now can we write, like we know the differentiation of log x is 1 by x, so differentiation of x to the power n would be, even we can write x to the power n as we can take this m in the beginning, so it would be m log x and it would be like n log y as per the standard formula of log. It will be easier to solve, like m and n both are constant, so m into d dx of log x, it would be 1 by x plus n into d dx of log y would be 1 by y into dy dx, as y is a variable and we are differentiating with respect to x, right? Similarly, here a would be constant, log of x plus y would be 1 by x plus y, and we need to again differentiate the x plus y part. It would be 1 plus dy dx. Similarly, for this part, it would be n into 1 by x plus y, and within bracket 1 plus dy dx. Okay, now we'll try to take all the dy dx part into one side. Okay, so what we'll get, we will get 1 by y, n by y from this part, and we'll be getting m by x plus y dy dx, m by x plus y from this part, and from this part we'll be getting n by x plus y dy dx minus n by x plus y. So this would be under dy dx. Okay, and from this part we have m by x, so we'll take this m by x in the next step to right hand side. So minus m by x, it would be only plus m by x plus y plus n by x plus y. Okay, now what would be my dy dx, right? So dy dx would be m plus n by x plus y from here minus m by x, okay, divided by this part, like n by y c, okay, n by y minus m plus n divided by x plus y. I hope you have understood up to this part, right? Now what we will do, we will clear the first part, we will just keep this part to get the last part of the solution. Okay, just wait a bit. From this part we need to complete the solution. Okay, so as you can see in the numerator we can write x into x plus y as LCM, and in the denominator we can write y into x plus y as the LCM. Okay, so if we go after this point, like dy dx would be now let me we do not need to take within the bracket, let me break it, like let me write mx plus nx, mx plus nx minus mx plus my minus mx plus my. Why? So we can cancel out minus mx plus nx, okay, and in the denominator we can write nx plus ny, nx plus ny minus my minus ny. So we can cancel out plus ny minus ny. So what is remaining? Let me clear this part now. So what is remaining? Like dy dx would be, in the numerator it would be nx plus my and we can cancel out this x plus y from denominator of both the numerator and denominator. Okay, so it will be only x, and we have nx minus my. Let me check whether any mistake here or not. Let me check. Sorry, it would be minus. It would be minus. Okay, so from here we can get by y. So we can cancel out this part from both the numerator and denominator. So what we left with, it's 1 by x by 1 by y. So it will be y by x. Hence we have proved that from the given expression the dividends can be found as y by x. Just go step by step as the way I have solved the problem. Pause the video if you require to understand a bit closely. Okay, I hope you would be able to understand. Not a very tough kind of problem. It's a bit a tricky one, you can say, right? So although if any problem occurs, you can always reach out to me. Okay, so let's move on to the next